Everybody, my name's Craig Isaacson. Thanks for coming to this session. I'm a systems architect at Sundog Interactive. I've worked there for 5 years now. That's where I've really got my feet wet with Salesforce, and it's been a great platform to work on. We're a marketing and technology company. We do a lot of work in manufacturing vertical. We do a lot of cool stuff. We do a lot of stuff with indirect sales, things like that. So within this presentation, I have some demos, and they're going to kind of go along the same lines as that. So once again, welcome to this session entitled Not in This Transaction, Asynchronous Apex. So we're going to go over everything asynchronous about Apex. So real quick, show of hands, how many people here have actually used Asynchronous Apex? Cool. Most everybody. There's a few that didn't, but that's awesome. Hopefully we can learn some new things. Maybe you can show me something. I can show you something. So we'll go over everything here. So if you want the slides, I have the slides at this URL. It's just in Google Drive. So go ahead and take a picture if you need that. And we'll wait till everybody's done. Real quick, we have a lot of content to go over, so I'd ask that you save any questions till the end. I'm going to try and have a few minutes for that at the end. And we also have demos. So the demos are in GitHub. So if you want the URL for that, that is here as well. Cool. So we're going to be talking about Asynchronous Apex. We're just going to go over what it is, why we use it, how does it work. We're going to get into the various different types and tools that Salesforce gives us. And we're also going to look into actually implementing it. So we're going to be doing demos around that as well. So we're going to go back to the future, well, into the future with Asynchronous Apex. So what is Asynchronous Apex? So basically, it's an asynchronous process as a process or a function that gets executed in the background without the user having to wait for it to finish. So really, it's just a separate thread being spun up from our initial thread. So if you think about Salesforce, every time you make a transaction, when we talk about asynchronous, we're just talking about moving creating a new transaction outside of the one that we're actually in. So there's a few different reasons why we would use Asynchronous Apex. One of the biggest ones or one of the most important ones that I feel would be user experience and efficiency. This one really revolves around making sure that the users are having the best experience on the platform. So Salesforce is a really fast, and we can build our code to be really efficient, but there might be times, let's say we have John Smith, he's a salesman, he's entering accounts, he's taking phone calls, he's updating contacts. That's going great, our system's fast, but what if there's a call out that he has to make to an external system? Maybe not as performant as Salesforce, so we want to make sure that he doesn't have to wait for that to be finished so he can keep on going with his job, so we can move that into an asynchronous process. Another reason is higher limits. So with Salesforce, we have limits. We respect the limits. They're a good thing. They make sure that everything's being fast, but with asynchronous, they actually, on some of the limits, are higher just because they're in that asynchronous context. So there's that, and then we have scalability. So let's say you had to update maybe 1 million accounts for some reason. You're not going to be able to do that in one transaction, so we need to have a way to break that up, and Asynchronous Apex is that way. And then if you've ever ran into mixed DML, this one's kind of a bugger. Basically, if you're inserting objects, then you're trying to insert or update setup objects related to that objects. So for example, group memberships with users, things like that, you're going to get this mixed DML. So this has to do with basically sharing with Salesforce. It's going to throw that error, and anything like that has to be moved off into a new transaction. So we're talking about Asynchronous Apex on the Salesforce platform. This is how it works. So basically we have, like I said, the shared tenant architecture. We're sharing the same resources with everybody else. Basically, we spin off a new transaction in that future context. It's going to be put on the asynchronous queue in that queue store, and as resources become available, they're going to be processed basically at that time. So if you want to know more about how it works, I have a link here to an article on the Salesforce developer site. This is where I got this graphic, and it has a lot of great information into how it actually works in the back end, more so than just adding it to the queue store, then it gets processed. So if you're interested in that, I would highly suggest checking out that link. So we're talking about Asynchronous Apex on Salesforce. Salesforce gives us a few different tools that we can use. They give us future methods, Queueable Apex, Batch Apex, and Schedule Apex. So with all of these tools together, we can basically use those in conjunction with one another to basically perform any business requirements within the limits that we have on the Salesforce platform. So we're just going to go ahead and jump in right away to future methods. Future methods are really simple. Fire and forget. All it is a static method on a class. It's going to be global or public. You have to be able to access that method. One thing is it only accepts primitives or collections of primitives, so strings, IDs, integers, things like that. If you need to send in a complex class, you can, but you have to use the built-in Salesforce JSON serializer, serialize that complex class into a string, and then once you're in the method, you can deserialize it and use it as you would any normal class or object. So one thing with future methods is you cannot monitor them. So once you start them, they're going to be there till they're done. You can't chain them. So once you're in a future method, you can't call another future method. They always return void because you can't monitor them. And you have a limit of 50 invocations per transaction with future methods. So we're going to hop into real quick to a code demo of what a future method will look like. So like I said, Sundog, we do a lot of manufacturing things. So one of real world requirement we had before was basically we have a lead coming in. It's being inserted or updated. The lead might have a product. Basically, they're saying that they're interested in a product, and we want to provide a generated PDF of that dynamic product page to that lead. Maybe throw it in attachments and then send it off in Marketing Cloud later on down the line. So one thing with that is basically when you are in the trigger context, you're not going to be able to make a call out. You're going to throw an exception. So we have to throw that into a future context. So this is a real simple method. This is kind of what it would look like. So basically, we have our @future annotation at the top of the method. It's public static void. Save product literature. We're just going to pass in a lead ID. And we're just going to do a query on that lead. Create a new page reference, passing in that interested product that lead is interested in. Then we're just going to create a new attachment. We're going to use the get content as PDF as the blob for the body of that attachment. And then we're just going to set the lead ID as the parent on that attachment and basically insert that attachment. So this is very simple, simplified. This will work if you're just doing one lead in one transaction. Where this fails is, let's say you are data loading or for some reason inserting or updating possibly 6,000 leads. So just with limits, you're limited to 50 invocations of future methods per transaction. So even if we sent in the max callout limit for a transaction, which would be 100, we would be running into errors with that. So this is just an example, and this is kind of iterative of how we get to the end state. So a lot of times when you're developing, you'll start with future just because it's the easiest thing to do, but then once you're in there, you'll realize maybe that's not the right thing for what I need to accomplish. And that leads us to Queueable class. So a Queueable class, very similar to future method. It's, instead of being just a method, it's actually an instance class. So that instance class implements the Queueable interface. It can be monitored or aborted. So we can actually do stuff with that future class while it's on that future queue or while it's actually being ran. And we run it by invoking system.enqueueJob while passing an instance of the class. Future methods, or excuse me, Queueable classes can be chained. With one caveat, if you're making a call out, you cannot chain it. So that's one thing we'll have to work around. We could show that in the next demo. And then it always returns that job ID. And with that job ID, you can actually do queries in your code to query out that job. And that's where the monitoring or boarding comes in. And you're limited to 50 enqueued jobs per transaction. So for this demo, we're just going to do a continuation of our future. And we're going to hop into our master trigger handler. So at Salesforce, we implement the master trigger pattern. If you want to know how that works more, all the code for that is in GitHub. But just real quick synopsis, every single object is going to run through its own handler class. And each handler class is a singleton class, so every property in this class is available throughout every single transaction of the trigger. And basically, we have before insert, before update, so all of the different methods are going to be called depending on the context of that trigger. So real quick, we're going to look at this before update. We're basically just looping through the leads in our trigger.new. We're going to check to see if the interested product is not null and if it's different from the one before. If it is, we're going to add that lead ID to this df16q lead ID set. And this queue is just the queueable class we have as an instance setting on this class. And then we're going to do the same thing for insert. We're just going to loop through the leads. We're going to check to see if they have an interested product. If they do, we're just going to add that lead ID to that lead ID set again. So then with this master trigger pattern, after everything's gone through the trigger, this finish method gets called. So we're going to finish this off by checking to see if that lead ID set is empty. If it's empty, we're going to enqueue that queue. So let's take a look at that queue and see what that looks like. So as you can see, we're implementing the queueable interface. We're allowing callouts because we're going to make a callout to get that page. And these are just our constructors for the class. And then we get down to the execute method. So the execute method in the queueable class is what gets ran when the queueable class is executed, which makes sense. So basically, we're going to loop through our lead ID set, querying for the leads. We're going to limit it by the amount of callouts we have for this transaction. So since callouts and things, anything to do with limits are always variable, they can change depending on the org, or Salesforce might up the limits like they do many times. It's always great to use the limits class to make sure you're not hard coding those limits and staying within the limits that you need. So basically, that's why we're limiting it there. And then we're just going to check to see that the callouts are less than, the callouts that we've used is less than the actual limit. And then we're just going to do that same thing that we did in that future method. We're going to do that page reference. We're going to basically get that attachment, create it, add it to the attachment list. And then we're going to take that lead ID set that we added all those leads to, remove the lead that we just processed, so we know that we processed them. And then real quick, we're going to check to see if that attachment list is empty. If it's not empty, we're going to insert that attachment list. And then basically, if that lead ID set is not empty, we need to do another queue again. So we're going to basically make this queueable class recursive. We're just going to keep on iterating through this until all the leads have been processed. So like I said, you can chain a queueable class, but you can't make a callout. So the workaround for that is to actually create a new future method in this class that just queues again. We're going to call this queue again method, passing in the lead ID set. And we're just going to use the system.enqueue job method again, just to spin that off. So that leads us to batchable class. So batchable class is very similar to the queue. It's an instance class that implements the database.batchable interface instead of the queueable interface. Like the queue, it can be monitored or aborted, and we can run it by invoking database.execute while passing an instance of the class, as long as there's another way to do it too, which you'll see in the demo. And batchable classes can be changed. So in the finish method of the batchable classes, you can call other batchable classes. And just like the queuables, we get returns a job ID, which we can use to monitor or abort that batchable class. So batchable classes are a little bit different. A lot of times they revolve more around large data sets and iterating over those big pieces of data. So because of that, we're going to do a little bit different demo. So this one is more related to leads coming in and basically routing leads to accounts based off a geographical location. So in the summer 16 release of Salesforce, they implemented a new geolocation thing for accounts, contacts, and leads that actually will automatically put latitude and longitude on those objects for you, so you don't have to use a separate service that's derived from data.com. The link in this slide is where you would see that if you want more information on that, but we're just going to use that right now for the demo. So basically the way this is going to work, we're going to have a lead come in. It's going to be inserted or updated. We're going to check a Boolean field, auto route lead. We're going to see if that's checked. If it's checked, we're going to query the closest account. And we're going to use those distance queries built into Salesforce to find the closest account for that lead. So basically, every lead's going to need a query. So that's where needing a batchable class comes into play. So let's hop into the demo. So just like, again, we're in the lead master trigger. We have a Boolean, should run routing batch. We're just going to use that throughout the class to find out if in that finish method we should actually run the batch. And we're just going to loop through the leads, check to see if that auto route lead's checked. If it is, we're going to set that Boolean to true. Same thing for insert. Set the Boolean to true if it's needed. And then in our finish, we're going to check to see if we need to run the batch. And then if we are, this is a little bit different example. We're actually going to take that batch and put it in the future 1 minute. So we're going to do that just in case we're doing a whole lot of transactions. We don't want to keep on spinning off new batches. So we're going to send it off in a minute, and we're going to basically do a query on cron trigger. So this is just all the scheduled jobs that we have available. We're going to look for this batch example, which is what we're going to call it. And we're going to see if it has a status of waiting. And if we actually do find a job that has that matches that criteria, that means there's already one waiting. So all of those leads will be processed the next time that batch runs. But if there's not, we're going to want to make sure that we schedule that batch. So we're going to use the system.scheduleBatch, which is kind of a mix between schedulable and batch class. We're just going to pass in a new instance of our batch class. We're going to call it the scheduled name that we need. This 1 is actually how many minutes from now do you want it to start. So we're just going to set it to 1 as an example. And then since we have to make a query for each lead, we're going to want to limit our scope to the batch class to the number of queries that we have available in our limits. So the batch class, very similar to the Queueable class, except for we implement database.batchable. So if another thing with the batch class is if you need the instance settings available throughout the entire transaction, every single transaction of the batch, you can implement database.stateful. So then you can actually have your instance variables available throughout each transaction. That's very useful if you're doing other sorts of operations. But for this, we don't need to do that. So basically in this start method, we're just going to create the query that we need. So we're just going to do a query on leads, where they have a longitude and latitude, and where they have an outer route lead equals true. Then we're just going to do this database.return. We're going to return the database.getQueryLocator, passing in that query. And that's going to tell the system to run, and that query is what it's going to run against, and that batch size is how big each size of those records are going to be when it gets ran. Default size is 200, and you can do anything. I think it's from 1 to 2,000. So this execute method, this is what gets ran when through each iteration of that query set from the limit. And we basically get this database.batchable context. You can use that if you need to do information with that batchable context. Otherwise, the actual records returned from that query is the scope. So we're just going to use that scope, and we're going to tell it to route. This is just a method that's going to loop through these leads that we got back from that query. We're going to set that out of route lead to false because we don't want it to get picked up in a subsequent batch. And then we're actually going to do a query on accounts. And yes, it's within this loop, so it's not typically good practice to do that. But since we're using the batch and we're limiting the size, we have direct control over that. We can do that confidently and not worry about hitting those limits. So then this is our query for the accounts. We're just going to query the accounts order by the distance closest to the lead itself, and we're just going to limit it by 1. And then we're going to return that account. Otherwise, we're just going to return a blank account. And then in here, we're just going to check to see if the account's null. If it is, we're just going to go to the next lead. Otherwise, we're just going to set our dealer account to that lead. Then we just update the lead list, and our lead's been routed to the right account. And then with the batch, after it's done through every single iteration of that query, this finish method will be called. This is another transaction by itself as well. So in here, you can do your cleanup stuff at the batch, or you can start new batches if you need as well. And that's pretty much it for batch classes. I'll hop back in here. So now we're going to talk about schedule classes. So a schedulable class is an instance class that implements the schedulable interface, very similar to the batch class, except for it implements the schedulable interface. You still have that execute method that gets ran. It can be monitored or aborted. You can invoke it by running the system.schedule while passing in the name of the class, passing in the name instance of the class, and then the cron expression. And you can also run it from the Salesforce, set it up from the Salesforce UI, right in the scheduled jobs. And they always return that job ID, so you can use that in subsequent transactions to monitor the schedule class. So this is what a schedule class would look like. Really, you can run any code you want, but this is just using the same example that we had with that batch. If you didn't want to do the basically starting the batch a minute from now, doing that kind of logic. If you just wanted to run it maybe once per day, you could implement a schedulable interface class like this, with basically just executes that batch. So this batch will get ran whenever you have this scheduled. And as you can see, we're just doing the database.execute batch like we had before, passing in the instance of the class, as well as the limits for the queries. So to schedule Apex, if you go to Apex classes, there's a Schedule Apex button. You can just click on that, and we have this great interface for going through there and setting it up. This will allow you to set it up at most once per day for the frequency. If you need to do more than that, you need to do code. And if you're going to do that, you can just run something like this in Anonymous Apex. So basically, this is just a start schedule method, taking in a cron expression. So we're just going to start this, or create a new instance of our DF16 schedule class. We're going to basically call the system.schedule. We have the name of the job, as well as the cron expression, and then the instance of that class. So the cron expression, those can get pretty intricate. So if you want to know more about that, I would highly suggest Googling some resources on that. There's a lot of great information. So now we're going to get into the monitoring asynchronous Apex. So debug logs, everybody knows that. You're in the developer console or in the Salesforce UI. This is where you'll go to see after the transactions have finished. If you're looking at feature methods, this is the only place you're really going to see it with any detail. We have our Apex jobs tab. You can go in here. Basically, you can see all of your jobs that are pending, completed, failures. You can go in here and just monitor everything that's been happening within your org. And then very similar, we have our ALD schedule jobs tab here. So this is just all the scheduled jobs that we have currently available for the org. We don't have any here, but if we did, you would see them in here, and you could abort them or do what you need with those scheduled jobs. So just as a quick recap, basically asynchronous Apex runs in a separate thread to do work in the future. We can use this to get around governor limits or to provide our users with a better experience. Like I said, Salesforce is that shared tenant architecture, so we basically share that queue store with everybody else. So when resources are available, that's when our stuff gets processed. Salesforce gives us a number of different tools to work with this. We have future, queuable, batch, and scheduled. And we can monitor asynchronous Apex through the debug logs, Apex jobs, and scheduled jobs. So Trailhead actually has a great trail for going through asynchronous Apex. So if you have any time, I would just suggest going to that trail and going through it. It has a lot of great information. And that's it for now. If you have any questions, feel free. I think we have about 7 minutes now, so. Yeah, you can do some math to figure out. If you know how many you have, you can just divide it by whatever the enumerator would be. Yep, if you use that get query limit, it's going to know that that's the limit that you want to do the batches by. So that's how many records are going to be processed in that query.
For the future, this one.
So that was more around the demo that we had since we were making that call out. So you're limited to 100 call outs per transaction. So basically, we would only be able to send in 100 leads to that method. And then you're only limited 50 future methods per transaction. So if we're inserting 6,000 leads, we're going to run into too many future methods.